What's up guys, welcome to this video about end-to-end testing. I'm Michael, the maintainer of Vendure.io, and this is a video where I'm going to show you how to do end-to-end testing in a test-driven development way, TDD, E2E. Alright, smash that like and subscribe button. Alright, let's get on with the video.
Should I
leave it in there? No more YouTube voice. Let's get on with the video. This is a screencast about plugin development and specifically about end-to-end testing. I want to introduce the way that I recommend doing testing when you're developing plugins. It's going to go together with a blog post I'm developing, which is on the subject of end-to-end test-driven development. So when you think about test-driven development, it often has the reputation of being kind of slow, difficult to maintain, flaky, unreliable. But I think when we're testing APIs, as in Vendure, you can really mitigate these problems with end-to-end testing. They can be fast, pretty fast, acceptably fast, reliable, easy to maintain. So I want to demonstrate that and also in the process show you a little bit about how I go about developing plugins for Vendure. Also, I want to say thank you to my GitHub sponsors, these people here. Thanks to your support, I'm able to spend more time doing content like this, which is what I really like to do. So thank you very much, and let's get on with the video. We're going to start off here with the plugin template. This is a repo available on GitHub, which has the skeleton, the boilerplate for developing a plugin. Since it's a template, you can actually click this button right here if you want to, and it'll generate a brand new repo based on that template. But in this case, I'm just going to clone it in the usual way. So we'll copy that. Alright, so I've cloned the repo here and I've opened it up in WebStorm. Let's just take a look at some of the things that it contains. Well, we'll start with the README. So we've got end-to-end testing kind of set up for us. That includes, I'll show you right here, the Vendure testing package. So we'll see a bit more about how that's working later. We also have a GraphQL code generator set up. That's going to help us to automatically generate TypeScript types from our GraphQL schema. We have ESLint and Prettier set up. And we have a whole kind of Docker compose set up here so we can run the server, the worker, and the database with Docker Compose. So the plugin template comes with a kind of a trivial plugin that's already partially implemented that you can then modify and change to your own needs. So if we start off with this file right here, API extensions, let's take a look at what we're doing. We're defining a new type called example. It's an object, it's an entity. It has a name, which is a string, and we can query it by ID, or we can query a list of them. There's some mutations for the admin UI. You can add an example, we can update an example, and all you change really is the name. So very, very simple and straightforward. Let's take a look at the actual definition of the entity for type ORM. So here we have example entity. It has one column, which is a name. So that's that. Let's see, we've got then a service, which is the business logic for dealing with fetching and updating and so on. So we call it example service. We've got a function here, get all items, which is the list query. Then we've got get item, which is when you want to get one individual one. We've got a function to add one and update one. Okay, and what I'll do is I'll run it and we can see how it works so far with no changes. So one thing I'm going to do before I run it is I'm just going to change the config a little bit, and I'm going to comment out this admin UI compilation step just because it's a bit slow and we don't care about it right now. So with that done, I'll then run the index.ts. I'm not running the worker because I don't need to right now, and I'm also not running it inside of Docker just because it's simpler to do it directly. So we have the server up and running now. So now let's take a look at the end-to-end tests. They're located here in this E2E folder. And this file right here, plugin E2E spec. And this is what it looks like. So the test runner is Jest by default. So the really important thing with our tests is this Vendure testing package. It exports some key kind of helper methods, functions, and so on. Create test environment, register initializer, and here we're using the SQL.js initializer. So the initializer is used to allow us to test against a particular database backend. So that can be SQL.js, SQLite, MySQL, Postgres, and others. This means we can run our end-to-end tests against the actual databases that we use in production. So, for example, the Vendure core framework, all the end-to-end tests are run in CI against 4 databases that are supported for SQLite, MySQL, MariaDB, Postgres. So in this case, we're going to be testing against SQL.js, which is a JavaScript implementation of SQLite. So the create test environment function, we pass it the Vendure config. It's exactly the same config that you would pass to your regular Vendure server, to the bootstrap function. It allows us to then configure the server exactly how we want it for this test. So in this case, we're testing our plugin, our example plugin. So we pass it in the plugins array. When we call that function, it gives us 3 things. It gives us the server instance, it gives us an admin client and a shop client. The admin client is just a GraphQL client that is pre-configured to make calls to the admin API endpoint. The shop client likewise makes calls to the shop API endpoint. As well as just making a GraphQL query, it has some helper methods, which I can just show you. So it allows us to set an auth token, change channels, log in as users, as super admin, and upload files. So these are just convenience methods which make it easy to test various aspects of our plugin. Okay, and before we start all the tests, we want to initialize the server. This is basically the same as bootstrapping the server, which it actually does internally. And then we also then can pass it data to populate the server. So we can define like products that we want to be in there. We can set customers that we want to populate, and other data like countries and shipping methods and payment methods and so on. That's how the database should be in the initialized state before we start running our tests. And once that's done, we can log in as the super admin and start running the tests. So let's take a look at the first one. We're gonna try and add an example entity. And we use the admin client, we make a query, we pass it a GraphQL document, which is this one right here. And then we're going to query the ID and the name, and then we're going to make an assertion that the name should be the same as what we passed in, and so on. So we've got tests for adding, updating, and then querying a list and a single item, and as well as querying a list and a single item in the shop API. All right, so let's now run those tests. Now the first time it runs, it's going to populate the database with that initial data with the products and customers and so on. So it takes a little longer. And now this is the key thing. If you want to do end-to-end tests in a kind of a test-driven development way, you really want to shorten that time that it takes to run the tests. So for example, this took 25 seconds to populate and run the tests. It's kind of a little bit slow. So one strategy that we have in Vendure is that when you're using SQLite, what we do is once we've populated the data, we actually save it to an SQLite file. You can see that right here. If I open that up, we can inspect it. Let's see, we've got our customer populated, a bunch of products, and so on. So that means the next time we run the test, we don't have to populate it at all. We just run the test directly, and the database is already pre-populated. So I'll demonstrate that. So the first run took 25 seconds. I'll run it again. Some of the initial setup time is just the TS node transpiling the TypeScript into JavaScript internally. So that means when we watch it when we run it in watch mode, it's even faster. So that was 11 seconds. Not bad. All right, so now let's start implementing a feature in this plugin. So one thing that's missing that I can see straight away is that we're not able to delete these example entities. So let's now implement that. So the first thing I'm going to do is let's go into the API definitions. And we want to define the API first. Now, one thing I notice is that we've got some errors here. And if I hover over here, it says it can't find these types. It doesn't know what paginated list interface is and so on. Now, this is just a matter of configuring your IDE. So WebStorm has a GraphQL plugin. And I think I can do something about that. Click the plus button. Okay, plus. I'm going to add a schema here. Just point it to the right place, to the shop. No, to the admin API. Okay. And what do I do? Press that. It's doing something. Executing GraphQL introspection query. Okay, and now it's pulled down this schema and it's put it in the schema.graphql file right in the root. So now let's have a look back to our API extensions. Okay, errors have gone away. It still doesn't like the extend keyword there, but I don't care about that too much. So let's see, where are we? Admin API extensions. We want to add a mutation here. So let's call it delete example. And as the input, we'll just take an ID, and we're going to return a deletion response, and that's kind of a convention in Vendure that when you're deleting something, you return one of these responses, which is just telling you whether deletion occurred successfully, that is deleted or not deleted, and you can have a message if there's a problem deleting the entity. All right, so now we've done that. So what I will do is I'm gonna start my watch process so that I'm building these changes. Let's stop the server, wait till the watch task has finished running. Okay, now I'll start the server, and what I'm gonna do next is I'm gonna run the GraphQL code generator. So it's going to be able to pick up that new mutation and encode it into the TypeScript types. So let's run the generate types script. Okay, that's done. So now let's go back into the test, and we're going to create a new end-to-end test. Okay, so we're going to say, have a test for it. Deletes an example. Okay, and the next thing I'm going to do is I'm going to define the GraphQL mutation. Let's create a new mutation. We'll call it delete example. Mutation, delete example, and we give it an ID. Let's see, it should come up now. Here we go. That's the GraphQL plugin of the IDE picking up on that when we updated the schema. And we'll select the results of that. Okay, so that's it. I'm going to run the generate types again now. After having done that, let's go back to our test. So now let's make the call. Admin client query delete. Can't type delete today. Delete example, and then we pass it the type. So so we get static type support for the query, for the mutation. Delete example. Okay, it's been generated for us, and then the variables is a second generic argument. it wants an ID. So what ID are we using here? We're going to delete the one that we created up here, so the ID is going to be 1. Okay, and then we make an assertion. What's going on with this? Oh, it's prettier. Okay, it wants to be formatted differently. And why is it upset about this? Okay, it's not used the value yet. We're going to do that now. We're going to expect delete example.result to be, and then we can use the enum type that has been generated, deletion result. That's coming from here. We're going to expect it to be deleted. And then I think what we can also do is attempt to get that one again. And we're going to expect that to be null now. Because once it's been deleted, it shouldn't be possible to query it anymore. Alright, so now let's run the tests. And we're going to say just config. Okay. Oh, let me run in watch mode. Okay, so let's let them run, and we should expect that deletes an example test to fail because we've not implemented it yet. So the first run's going to be a bit slower. Okay, good, one failed, which is what we expected. Cannot return null for a non-nullable field mutation.delete example. Very good. Okay, so now we're going to implement that deletion. So let's go over, first of all, we'll start in the service layer, and I'm going to create a method. Sync delete item. Okay. It's going to take a request context because that's required to ensure that our transactions are all working correctly. The args are going to be, I guess, delete example delete example. Oh no, it's just an ID, isn't it? So let's just say example ID. It's going to be of type ID. Do we have that? Let's import it. Okay, and the return type is going to be a promise, which will yield a deletion response. And that's coming from core as well. Okay. So let's do the most simple possible implementation right now. So let's say this connection, get repository, pass it the context. The type is going to be example entity, and we're going to say remove. I think remove is correct. No, first of all, I guess we want to make sure that it actually is a valid ID. So let's say const, I'm going to call it item. Example's kind of confusing me. I'm going to say get entity or throw, because if it doesn't exist, then we can just throw an error because they've passed the wrong ID. Entity type is example entity and the ID is ID. Good. Okay, so now we know that this item is either going to exist or that we've already thrown an error by this point. Oh, example ID, that should be. And then we're going to just remove that result. What is the type of this result? Okay. Let me see. Remove given entity from the database. Fine. Okay. Why don't we surround it in a try catch? Okay. So if we get this far, in fact we don't. We can just let's just await that. Then we can return the result. If it doesn't throw at that point, we can assume it's worked, I guess. So result is going to be deletion result deleted. There's going to be no message. Here, we're going to have the result is not deleted. And the message, we can say e.message, maybe. If it's not got a message, I can say let's see, I don't know, let's just cast it to a string. Maybe that's wrong, I don't know. You'll probably think of better ways to do this. Okay, so that seems like a reasonable implementation. And now we need to jump to the GraphQL resolver level and just hook that up. So here's our example resolver. Actually, we want example admin resolver, which is going to be active in the admin API. I'm just going to copy that so I don't need to type all that stuff again. Delete example. Right, we're using database transactions. It's a mutation. We've got permissions. Only the super admin is allowed to do this. Very sensitive operation. The arguments are going to be mutation delete example args, and that's coming from right here. And we're going to pass the ID, and we're going to pass it to delete item. The return result is going to be a deletion response. Okay, everything looks okay. Let's see what the watcher says. 0 errors. Okay, well, here we go. Let's run the tests again. So yeah, this is not as fast as unit tests, of course, but coming in around 10 seconds, 10 to 15 seconds. It's actually faster when I'm not recording a video. It's going to be more like 8 seconds or so when I'm not recording a video. It seems fast enough to keep you in the flow. What's going on here? Someone's not happy. Just encountered an unexpected token. So probably one of my auto imports from WebStorm has messed things up a bit. Let's go back and check. That looks okay. Let's check here. Oh, yeah, this is coming from the admin UI package. That's totally wrong. Okay, let me delete that. Let's re-import them from somewhere more sensible. From there. And this one as well. From there. Should not be uppercase like that. Not deleted. Okay, cool. This is real life. Things go wrong. What else? We've got another error. Where's this happening? Oh, here. That's it. Another one of those. Right. Yeah, one thing you got to watch out for. So let's import it from the same place. And all right, let's run these tests again. Okay, so now TypeScript is happy, no errors. So hopefully the tests are going to pass. No. Okay. Aha, yeah, okay, that makes sense. So I've deleted the example entity, so the shop API is failing now because it was expecting an item still to be there, and now I've deleted it. So yeah, that's one kind of thing you've got to remember with the end-to-end test. They kind of run sequentially. Each one depends on the previous tests because you're storing the state in the database as the test suite executes. So one thing we could do here, I could take that out, for example, and put it there. And that should fix it. Another thing is that I could kind of create a new entity inside this shop API block. That's probably better because then it makes it independent of what's been happening around it. And that's what I would probably do if I was spending more time on it. Just for now, let's make the tests pass. Okay, so now we've got the test passing, so that feature's done. All right, so now there's one other thing I want to implement on this plugin. The requirement is this. When an example is created, we want the developer to be able to supply a callback function, which is called whenever it's created, and then they can kind of react to the creation of one of these example entities, okay? So the way I think it should be done is we should add it to the options. So if we go to the plugin, we see that we have a static init function. This is just an idiom. It's just a common pattern used by Vendure plugins to be able to configure the plugin. So we pass it an options object. If we jump over here, we've got just example option. I think it's not used. We don't care about that. So let's replace it, and we'll make it so we can supply an onCreated function. And that's going to be of type, it's going to get the request context, because it's always handy to have that around. And let's pass it the example item. And it's going to be of type example entity. Okay, and it's going to return a promise void. Oh, I guess I should define it like this. Okay, and we'll make that optional. So now let's see how we would test it. So we'll write the tests for this first, because this is all about the TDD, test-driven development approach, where we're writing the tests first. I don't always practice it like this, but I find it pretty useful, pretty productive. That means now we can say example plugin.init, and now we should be able to supply an onCreated function. So what should we do here? Well, how can we test whether this has been called? So a typical way to do it is to use like a kind of a mock function, a spy. So we can say onCreated spy equals jest.function. So this is Jest's way of creating a function which we can then kind of check when it's been called. And we just call it like a regular function. We'll pass it those two arguments. Okay, and what does it not like? It should return a promise. Actually, maybe that's too restrictive. It should return a promise or not a promise. I guess that would be a better way to do it. Still not happy. Let's have another look at this. Actually, I can see that when I'm making updates here, the TypeScript's not finding any errors right now. So I've got a feeling like this is some kind of IDE config problem. WebStorm is using its own TypeScript checker, different from the actual one that's compiling our code. So I'm going to ignore that for now. Now let's write a test for this. So so we want to say that when it adds an example, we want to test that this function is being invoked. I'll do it here at the end. Let's call it invokes onCreated callback. Okay, and I'm just going to kind of copy this part. Love to copy paste. Other one. In fact, I don't even care about any of that return value. I'm going to delete it. No, I'm not going to delete it. I do care about it. So after this is done, we can make an assertion. Expect. First of all, what do we call it? Something spy. onCreated spy. I'm going to say mock clear just to start fresh for this test. Then I'm going to expect onCreated spy to have been called once. And they can also assert what it's been called with. So mock.calls, that's an array of calls. And let's say the second argument to the call, so index 1, should be this new example. So can assert about the ID of it should be equal to this ID. Yeah, I guess that's kind of what we want to test. Okay, so it's already running the test now because it's in watch mode. And what's up with that? Oh, to be not to have been called times. Okay, we're running it again. Now that I fixed that assertion. So there's 2 failing tests, okay. Oh yeah, okay. So yeah, we affected the number of items here in this list. Right, so we expected the number of calls to this spy to be 1, and it gets called 0 times. That's fine. And you know what else I can do now? I'm gonna put this deletion one back here, and we're gonna delete. Let's delete number 2. And now that'll kind of reset the number of items back to how it should be there. So let's see, we should get just 1 failing test now, I hope. 1 failing test, good. So now just this one that we expect to fail is failing. Now let's go and implement the feature. So we want to go over to the service layer here, example service. Now we're already injecting the options up here, so that's convenient. So add item, this is where we want it to happen. So here we've saved the example. Okay, so we should be able to say something like this. If this.options.onCreated, if the type of that is function, then we're gonna invoke it. So let's await it as well because it might be asynchronous. And we're gonna pass it the request context, and we're gonna pass it the example. Okay, let's see, moment of truth. Rerun our tests. Yeah, there's something weird going on with TypeScript. I'll probably dig into that later. I don't want to bore you with it. Haha, we're still failing. Okay. Yeah, that's right. It should be actually just, it should be 2 because we have a layer in the GraphQL layer. We're encoding and decoding entity IDs to add a T in front. That's just a convention that we have in the end-to-end tests. But internally, it's called with the actual database ID, which is just the number 2. It's a number type rather than a string. So let's run this again. Okay, now everything's passing. So I hope that gives you some insight into how I go about developing plugins using the end-to-end tests as the driver for the development of each feature. Yeah, I found after many years of approaching testing in different ways, like from 0 tests for a long time to going like 100% in on unit test everything, I've come to the position where, particularly for testing APIs like this, end-to-end tests just give the most value for the time invested. At the same time, the API is the public contract. It's the most stable part, or it should be the most stable part of the application. So the kind of traditional flakiness and hard to maintain aspect of end-to-end tests is negated by that fact. Your API should not be changing, so the end-to-end test should just stay as is. Maybe with major versions you need to tweak them a little bit, but they're very stable. Like in the Vendure call, we have about 1,000 end-to-end tests that run like every push to GitHub, and they're very, very stable. Very rarely do I have to kind of go in and fix some kind of spurious failure. So it gives them a huge degree of confidence, and I advise that this is a way that you should be really testing your own custom plugins, your own business logic, particularly those critical things to do with like financial transactions and stuff that you really want to make sure that you get right. Okay, thanks for watching, and see you next time.